Welcome guys, welcome to my video. So this video, let's prove this inequality. So we have a1, a2 up to a3 up to infinity, and they are all different. So they are integers, they are positive integers, but they are all different. Then we prove that for all n, and we have this, right? AK divided by k squared, k from 1 to n greater or equal to 1 over k, k from 1 to n. So before I start, let me spend a little bit time to introduce my channel. So I'm Eric, and if it is the first time you come to my channel is about teaching mathematics and physics from high school to graduate school. So, and if you're interested in absolute mathematics, like group theory, then you can check it. But on the other hand, I will also upload the funny math question every 1 to 3 days, and I will solve them one by one and share with you guys. So if you feel bored in your working days, you want to have some fun, then you can go to my channel and you can wait my video. I will upload every video like in the noon. In the United States time, so you can click the button, the notification button, and subscribe to my channel, so you will not miss my latest funny video. And leave a comment below and what you like me to do in the future. Or okay, and that's it. So we don't waste time and proof. Okay, so this problem looks a little bit strange, right? So you need to guess how to do this. Okay, so let's make an observation. Since they are all different, right? So what is the lower bound for a1? So a1 should be greater or equal to 1, right? Because a1 is an integer, positive integer, right? Natural number. Or what about a1 plus a2? Since they are all different, right? So a1 plus a2 must be greater or equal to 1 plus 2, which is 3. And a1 plus a2 plus a3 should be greater than 6, while 1 plus 2 plus 3, because they are all different. So we know that a1 plus up to an should be greater or equal to n times n plus 1 divided by 2, right? So once we notice that, then it's enough to give the proof. Okay, so let's see the idea. So let's say S is a k squared a k minus k, k from 1 to n. So our idea is to show S is greater than 0, right? Okay, so let's do it step by step. So this term is just a1 divided minus 1 divided by 1, it's 2 squared a2 minus 2 up to n squared, right? Let's maybe focus on the first two terms to get a feeling. Okay, and the first term is greater or equal to okay, so if you combine these two terms, so notice that my technique, I claim that these two terms were greater or equal to 2 squared minus plus a1 plus a2 minus 1 plus 2. Okay, and why? You see, I can save. I know that a1 minus 1 is greater or equal to 1, right? So I know that this term is greater than 0. So I can shrink this 1 to 2 squared and then combine these two, right? So I get this inequality. This is a trick, which is it's right, ak minus k squared. So you know this term is still positive. So that means you can shrink this term into, you can prove this term combined with the k equal to 3 terms and get this 1 plus 2, 1 plus 3 divided by 3 squared. And then k from 4 to n. Okay? You just combine the k equal to 3 terms and you keep going, right? So, and you know that this term is still greater or equal to 0. So finally, if you keep going, then you will prove that it's obvious that you prove that greater or equal to 1 plus n squared, a1 plus a2 plus an minus 1 plus 2 up to n. Right, and these are greater or equal to n plus 1 divided by 2, which is exactly what I said, right? So greater or equal to 0. Okay, so let's prove. Very straightforward. See you guys in the next video. Subscribe to my channel. Thanks.